Hello everybody, welcome to my course. I will try to help you create your first map using a combination of software and skills. I have been studying GIS for around 6 years. I graduated my cartography bachelor degree and a geomatics master degree. I made a transportation map that was distributed in over 10,000 copies. I created some web GIS projects and have some commercial experience working on GIS data validation. I'm also studying for a PhD. First of all, GIS stands for Geographical Information Systems, as you perhaps know. It is represented by multiple software options that help you introduce, store, manage, analyze, and represent geographical data. By geographical data, I mean any kind of data that has a spatial coordinate. It is data about an object situated in the three-dimensional space of the planet Earth. The most common output of the GIS system is a map. However, you can output data under different formats, including tabular or statistical diagrams. What does introduce mean? It means that GIS software allows you to create new data about some geographical features. For example, you can digitize new rivers close to your home. This means drawing on top of a satellite image or a previous map the line that would represent the river at a particular scale of detail. To digitize simply means to draw in GIS. There will be a video in which I will show you exactly how and what that means. The most important thing about GIS is the data it uses. Without the spatial dimension of the data, GIS would simply be like any other software that uses tabular data. And by tabular I mean any data that can be represented in an Excel spreadsheet. We will open Excel spreadsheets and see how we can make the data have a spatial dimension. GIS is able to store the data in a number of different formats, from shapefiles, KML, DWG, and database-specific formats, and many others. Storing the data in a database is safer and better. However, at the beginning we will store them in the less safe format called shapefile. I will teach you how you can create these types of files in QGIS. It is also possible to analyze the data by applying various functions to it in GIS. The management aspect of GIS allows you to create new data and modify or delete previously created data. Finally, it is possible to represent the data on a map. And I will show you how to combine a GIS software with a free graphic design software called Inkscape to make an enhanced map. Hopefully you can create a great map that you can get money for. GIS can be used in a wide range of domains, from commercial fields like marketing, for example showing the position of a restaurant in a city on a small presentation leaflet, or making a web GIS app that shows the location of multiple restaurants in your area. Military, for example, showing the position of your military units, emergency response units, showing the locations of hospitals, emergency units, the location and different types of crimes within a city. It can also be used for urban planning, agriculture, risk maps, transport routes. One of the best known use of a GIS is Google Maps, that uses a combination of images and vector layers to help you navigate through a city interactively. I will leave some books in the description box below. Please use them to find out more about GIS.
Hello and welcome to my second tutorial. In this tutorial I will guide you to download your first GIS software. It is called QGIS and it stands for Quantum GIS. It is widely used in educational and commercial environments and integrates many of the functions of other open source software as well as proprietary softwares. You can download standalone or in a suite of softwares. I will go through the first option. You will find all the links necessary in the description box below, so no need for you to type based on the video. As a standalone software, you can download it by going to QGIS website. You can type QGIS in your search bar or simply go to www.qgis.org. There you will see which is the latest version that you can download the software in. In my case, in November 2016, it is 2.18 Las Palmas. We could download the very last version or the last stable version. We will go with the last stable version, also called long-term release. So if you click on downloads, you can choose the long-term release. files for 32 or 64-bit. If you are not on Windows, you have the option of going to All Downloads at the bottom of the main screen and choose the download suitable for the operating system you have, either Mac, Linux, and many others. You can also download a different version of QGIS if you have issues with this version. Simply go to qgis.org/downloads. It is a list of all previous versions. The download file is a small to medium-sized file of 350 megabytes. While it is downloading, you can read more about QGIS, either from the website or from Wikipedia. If you will enjoy working in it, I advise you to support their cause in whatever way you can. Also, please read the documentation whenever you need help with any issue of QGIS. You can find it under the documentation tab on the website. If you happen to have come across a more complicated issue, you can write it in the comments section of this video below or use the GIS Stack Exchange forum. This is a great place where there are many clever people waiting to answer your question. After the software has downloaded, you need to see where it is on your computer. Usually it is in the downloads folder. It comes as an executable, so you simply need to double click it and follow usual steps for similar installations of other non-GIS software. It is recommended that you close all other applications before starting the setup. Click Next on the first screen. Read the license agreement. After that, accept it. Now you can select the path by browsing to the preferred installation folder or by typing the address on your PC. You can read how much space it needs. In my case, it's 1.5 gigabytes. You might want to download some sample data. However, I will teach you where to get free and good data in the next tutorial. Click Install. Now I will show you how to install Inkscape. This is a free open source graphics software. Please go to Inkscape's website, inkscape.org, from the links below. You have the option of selecting the download depending on your operating system. There's also an option to select a previous version of the file by going to inkscape.org/en/release/0.91 and the slash at the end, which happens to be the last version. However, in the right side of the website, you have the option of selecting a different version. You can also read what is new in that particular version. Once the file has downloaded, double-click the executable. Select the language you prefer. It is preferable to close all other applications while running the setup, similar to QGIS. Now please read the license carefully and accept it. You now have options regarding the installation. You can choose to install it for all users, to create shortcuts, for example on your desktop, decide about additional files like examples and translations. Install as much as you want. Click Next. Now you can select the destination folder. Browse for a path where you want Inkscape to be installed, similar to QGIS installation. You can also see how much space is required and how much is available on your disk. Now you only need to click Install. After a few minutes, the installation will be completed. Click Finish. Thank you for viewing this second tutorial. In the next tutorial, I will show you how to download data. All the best. Goodbye. Hello everybody, welcome to the third tutorial. Now I will teach you how to get data to using QGIS. Obviously the most important aspect of any GIS project is the data. The better the data is, the better your map will be. Important aspects to look for GIS data is to be complete, to represent the area of interest at the desired scale. For example, you don't need every meander of a river if you are working on a small scale map. To not have errors, either in positioning or in attributes, and to be as affordable as possible. Depending on your budget and project size, you might decide to buy the data, to collect it yourself, or to use freely available data. In this tutorial, I will teach you a combination of the last two. How to combine free data with data created by you. The map we will create is a dual transport map for a city, showing public transport and bike routes. The data we will use is from OpenStreetMap. This is a free data source. To download OpenStreetMap data, please go to the website visible in the description box below, download.geofabrica.de. They make bundles of OpenStreetMap data that you can freely download. Please choose your continent, country, and click on the shp.zip file. You can read more information about the service from the technical details page. The file comes as a zipped file which you need to unzip. After unzip is done, the folder with the data will look like this. Each shapefile consists of more files that have different information and need to be kept on the computer in the same folder as the shapefile. I will not go for now into detail what each file means. The advantage of having the data in a database is that you will no longer see each of these files, but they will exist in the database. So that makes it impossible to delete the files by mistake. However, for now we will keep them in this format. Please make sure you don't modify or delete the files by mistake. To import data in QGIS, please open QGIS by double-clicking the application on the desktop or by searching QGIS in your Start program search bar and click on the link that says QGIS Desktop. When QGIS opens, you can read some of the tips and then close that dialog box or click OK. Then you will have to click on Add Vector Layer, the first button from the top of the left-hand side Layers panel, or by going to Layers, Add Layer, Add Vector Layer. We will add some of the files from the OpenStreetMap data. You can also use drag and drop. Another way of showing OpenStreetMap data as a background in QGIS is by importing it through a plugin. A plugin is an extension of QGIS created by different people. We will use the plugin called Open Layers. If you do not have it, you will need to install it. Click Plugins, Manage and Install Plugins. In the search bar, type Open Layers. You can read the description on the right and then click Install. Once it is installed, you will have a new option in the Web menu, Open Layers Plugin. Go and click on OpenStreetMap. This will show a base map that will contain the same information as the shapefiles we have just downloaded. As a source of data, I will mention another good one, which is naturalearthdata.com. However, we will not use it in this course. The website shows good data that you can use to make world maps, country maps at small scales. For geographical data, the most important aspect is the coordinate system. If the data represents the same area, you will need to have all of the data in the same coordinate system. If you are not familiar with a coordinate system, this is a mathematical system of axes that allows for the representation of each object found on the surface of the planet in a two-dimensional plane, with the x-axis being the north-south direction and the y-axis being the east-west direction. Thus, you are able to distinguish between the position of a point from the position of another point in the same area. Because the Earth is a unique ellipsoid-like shape, projecting the points from its surface to a plane needs to be done by mathematical equations and will introduce some errors. Selecting one of the coordinate system means selecting the mathematical equations that will ensure the errors are minimal for your area. The coordinate system of these files that we opened is the same as the coordinate system of Google Maps, called WGS84. Geographical data from a GPS comes usually under geographical coordinate system or latitude and longitude in degrees, minutes, seconds. Each country in the world has a specific coordinate system that allows for its area to be best represented so that the errors are minimal. It would be best if you would search for your country's specific coordinate system and use that one. You can set up QGIS to have a particular coordinate system by going to Settings, Options, CRS, and then use a default CRS. Please click on the right hand side icon to select the coordinate system. Now you can select it from a long list, either by searching or by scrolling down. Also make sure the Enable on the Fly reprojection by default setting is enabled. In this way, when you import the geographical data in QGIS, it will read that it has a different coordinate system, however it will convert it on the fly or on the moment to the coordinate system of your project. This means that the data will remain in the same coordinate system on the disk, however QGIS will show it as if it had the coordinate system of your project, because QGIS will perform a temporary transformation that is only available in that session. This allows you to keep working with the data. Alternatively, you can reproject the data to your preferred coordinate system when exporting it. Right-click the file, Save As, CRS. You can click on the right-hand side icon, select CRS. We will be using data with different coordinate systems, so it is important to define the coordinate system in QGIS. Thus, even if you forget to convert the data, QGIS will reproject it on the fly. For best practices, please read as much as possible about any data that you are importing. It usually has metadata, which states who created it, when, what does it represent, and how you can use it from a license point of view. Some data may be too old for your project or may require an agreement with the owner. Thank you for viewing this tutorial about data download. In the next tutorial, I will show you how to create data. All the best. Goodbye. Hello and welcome to the fourth tutorial. Now I will show you how to create data in QGIS. If you saw my previous tutorial, you remember that at the beginning of each project you need to set the coordinate system of the project. You can create a new vector layer from Layer, Create Layer, Shapefile. We will create a polygon representing the area around Oxford. So we need to tell QGIS that this will be a polygon type layer. The coordinate system can be WGS84 or a local coordinate system that represents the area with minimum errors. WGS84 is not good for areas above 60 degrees of latitude. It is not needed to create a new column currently, as we will not give attributes for this layer. In the future we will create layers with attributes. Click OK and then you can save it. To start digitizing, you will need to have the digitizing toolbar visible. If you do not have it, please right-click in the toolbar area and select the digitizing toolbar. We will need to have OpenStreetMap data as a base map. Please go to Web, Open Layer, OpenStreetMap and click on OpenStreetMap. You can use the mouse scroll to zoom in and out. You can use the Pan Map button to move the map to the west, east, north, south directions at the same zoom level. To start editing, toggle Editing, then click on Add Feature from the Editing toolbar. Now you can create a polygon. To do this, simply left-click for the first vertex and then for each consecutive vertices do the same. At the end, you need to right-click. Do not worry about the position of the vertex, you can edit that later. Okay, we have created the area. To edit any vertex, click on Node Tool. Select the vertex, that will become blue, and then left-click and drag it around. We have now created the area of interest. Obviously, since we want to make a transport map, some transport vehicles will travel outside of that area, so it is best to have an area bigger than the area of interest. To see how big the area should be, I will show you how the final product will look like. Please go to Project, New Print Composer, create a unique title, for example Oxford map. Click OK, and now you will be able to create the end product. When you will want to open the composer again, you need to go to Project, Composer Manager, select the correct composer and click Show. First, you need to select the presets in the composer. This means how big will your map be. I will select an A4 map. This depends on where the map will be sold and how much detail you want the people to see. A bigger map size has more details but is more expensive to make. The orientation I will choose is portrait, since Oxford looks to be more developed on the meridian. From the presets you can also select the export setting. The resolution is best to be above 90 pixels, with 300 being a very good resolution. This will have an effect on the export file size. The bigger the resolution, the better the quality of the product, but the more megabytes it will occupy on the hard drive, and the longer it will take for QGIS to export it. Click Add New Map, then left-click, drag and drop on top of the white paper to fill most of the space. Later you can drag the corners, move the whole area by holding the left click, or delete it. You can also zoom in and out here to see the map closer or further away. The other zoom buttons affect the scale. Zooming in will give you a larger scale, while zooming out will give you the area at a smaller scale. After you have placed the map canvas, you can choose what the scale will be. If you don't know too much about scale, read some resources on the internet or from the resources I will put in the description box below. To be able to pan around so that you can see an area to the right or to the left, you have to click Move Item Contact and then left click on the map and drag, just like panning around. So now we know what is the best scale to show the map at. If we want to make an A3, we will have to rescale everything. Click Select Move Map Canvas to be able to modify the size of the map drawing. As you can see, the scale is bigger now. More details will be visible. Oxford is rather a weird shape, and I think I will need to reconsider the map layout. I will switch to a landscape. Now we have a generally good view of the area of interest. We might modify the scale in the future, but for now it is okay. You can save the template. We will come back to the map composer later this tutorial. So now that we know what the extent of our map is, we can create the polygon. We can see the extent at the same scale as it is in the composer. Simply type the scale in the lower part screen of QGIS. However, the extent will not be exactly the same since the screen we are showing the map in QGIS is smaller than the map size that we set in the composer. You can check what the coordinate system is currently for the project by left-clicking the lower part area of the QGIS screen. From the new window you can select what you would like the project's coordinate system to be. All the layers will be reprojected on the fly to that coordinate system. The area polygon created is only to allow us to clip the desired shapefiles that we have downloaded from OpenStreetMap. You can now save the edits that you made and stop editing. To stop editing, simply click on the toggle editing button. Once you have created your polygon, you can move on to the next tutorial, which is data manipulation. Don't forget to save the project by clicking Project Save As. Thank you for viewing this tutorial. All the best. Goodbye.
Hello everyone, and welcome to the 5th tutorial in this course, Data Manipulation in QGIS. This will be a rather short tutorial, but highly useful. With the shapefile created earlier, we are now able to cut the OpenStreetMap data to our desired size. Please import OpenStreetMap data in QGIS. You can do it with drag and drop or with the import method from QGIS. Click on Add Vector Layer, source type equals File, click on Browse button. You need to browse to the path where the data is and click on the .shp file. Click Open. I will import railways, roads, water and waterways. If I zoom to the layer extent, you will see these layers that cover the entire United Kingdom. Now we clip all the layers based on the area of interest. Click Vector, Geoprocessing Tools, Clip. Input layer has to be the vector layer that we want to take data from. So in our case it is, for example, waterways. Clip layer has to be the area of interest. This always has to be a polygon type layer. Make sure the Add Results to Canvas is ticked to be able to see the resulting shapefile at the end of the process without the need to import it. Click OK. It is an operation that runs by itself. You do not need to do anything else. Do the same operation for each layer from OpenStreetMap. For some it will take longer,
or some less, depending how much data there is in the original OpenStreetMap file. After you have finished clipping, you can keep the clipped layers, remove or render them invisible. To make them invisible, you need to tick the square to the left of the layer in the Layers panel. To remove, right-click on the layer and then click Remove. You can also find some links in the description box below that will help you if you have any issues. Thank you for following me in this tutorial. In the next tutorial we will create more data and soon we will be able to create the final map product. All the best, goodbye. Welcome to the 6th tutorial in this course. Now that we have the extent layers and other layers that will make up the base map, we need the thematic layers. The thematic layers of our map will be our own creation, the layers that will distinguish it from a regular general map. In our case, these will be the public transport routes and the bike route. We can create different types of layers: lines, the actual routes, points, the bus stops, cycle parkings, etc. Create a new layer, like in the previous lesson, lesson 4. This time it will be a line with the same coordinate system. It will show the bus routes. You can add a new column this time, call it bus number. The type can be text or whole number. You will write here what the bus route number is. I recommend it to be a text, since bus numbers may contain letters also. You can choose any length desired. 10 should be enough. Click on Add to Fields list. You will see it now in the fields list. If you want to remove a field, simply click it and click Remove Field. To digitize a line, left click on the map where the bus line begins, then left click at the first curve the road takes, then at the next, and so on until the last vertex. When you need to do a right click or a double click, make a polyline that follows as closely as possible the bus routes and/or bike routes. Where can you get the data about bus lanes from? Well, you can use an already existing map made by the authority for public transport in your city, or use Google Maps. They have data about bus transports in some cities, or you can even collect the data yourself. This is obviously easier in a small town rather than in a metropolis. In theory, these maps should be publicly available and you should be able to copy the data. Make sure you are not copying data from a copyrighted map without the owner's permission. Then you can create a new shapefile for bike lanes. You can add attributes if you want, since some bike lanes are bidirectional, some share a bus lane, some are in the park, others on the carriageway. I will add a description column, type text, size 80. You may want to create a layer for the parks or vegetation area as well, to distinguish it from the built or residential areas. It is exactly the same as making the polygon layer with the area of interest. You may add a column for the name of the park. Similar to this, you can create other layers that will help the users of the map navigate easier through the city, like touristic buildings, monuments, shopping areas, cinemas, sports stadiums, and many others. Add a shapefile for bus stops. Again, you can add attributes like bus name. Start adding points wherever there is a bus stop. This might be a long process. However, you can find this data already digitized in an OpenStreetMap layer, for example the OpenStreetMap layer called Transport of type Point. You can use other layers from OpenStreetMap for representation orientation purposes. Places.shp of type Point has information about neighborhood names. Traffic has information about bike stands. POIS has information about bike rental. Also, the roads layer has lines which are classified as cycleway, so you can use more data from here instead of manually collecting it. Simply clip these layers by the area of interest. Let's say you found some data that you need from one of the layers. How do you only select that data? Well, there are two ways. Let's say you want to select only the bus stops from the transport layer from OpenStreetMap. You can create a search by opening the attributes table, click Select Features using an expression button. This search is similar with an SQL search. The text of the search has to be field name equals field value. To type the field name, you can simply type the name if you know it, else you can select it from the fields and values list. Double click on the F class. We get all the possible values of this column by clicking all unique values, and then double click bus stop. Now you need to export this selection by right clicking the layer, save as, make sure save only selected feature is ticked, browse for a path, give it a name and click OK. Now you'll have a layer that will contain only the bus stops from the OpenStreetMap data. You can also do a clip action on this selection if you forgot to do the clip in the previous step. Make sure you have the use only selected features active. In the next tutorial, I will show you the second way of selecting data. Thank you for watching this tutorial. All the best. Goodbye. So in the previous tutorial, I showed you how to select data from a layer. But there is an easier way, and it is part of the representation of a layer. The second way is to simply represent only the bus stops from this layer using the Style tab. This tab is similar to Symbology in QGIS. Select Categorized, column equal F class, click Classify, and then remove every other feature type except for bus stops. Now your map will only show the bus stops, however the other features still remain in the layer's attributes table. And in the future you can choose to represent more or less of the classes. To remove these types, simply click Delete in the Style tab after you have selected them. We can also show their labels. Go to Labels tab and click Show Labels for this layer. Label with Select Name from the drop-down. I will show you later more details about the labeling. Let's see how it appears in the Map Composer. If we remove one of the layers, for example the background, we need to simply move to the left or right of the map with Move Item Content for the view to be updated. To select a background color for the map, go to Project Properties, General, Background Color. After you change the background color, you need to remove the current map and add the map again in the Composer. As an intermediate step, you can choose to export your map just to make sure it would look like you want it to look. In the Map Composer, click Composer, Export as PDF or JPG. If you want to use it later in Inkscape, you can choose to export it to SVG. We will export it to PDF first. We might want the label of the bus stops to be smaller. Double-click on Bus Stop, Labels, Text. You can change the size, the type of the text. Some labels are on top of the actual bus stop symbol, so we can change their placement by Placement Offset from Point and introduce a value in millimeters. Before you save again, make sure you close the current map view in the PDF viewer, otherwise it will not save. We can also choose a symbology for the roads. Right-click Properties, Style. Since we are dealing with free and crowdsourced data, we cannot know for sure that the roads have been correctly categorized, so we need to check. I think it is easier to visually check. So first let's categorize the data. You can read in the wiki OSM what each category signifies. Please go to the link wiki.openstreetmap.org/wiki/map_features. Since we want to show the roads, we will need primary link, secondary link, residential, tertiary link, trunk link, and motorway for main representational purposes. This means that these are the primary roads which are very important for a map. For secondary representation purposes, we will need also footways, unclassifieds, service, track, path, living street. Basically, since volunteers with various degree of knowledge and satellite image reading abilities have digitized this data, it will have errors in categories for sure. What I do is simply show all the roads for main representational purposes with one size and color, and the secondary representational purposes objects with a different color or size. It's a big generalization, and these roads are purely for orientation purposes. The main layer in our map will be the bike or the bus routes. My recommendation is to check visually each road if it has the correct type. Hopefully you know a thing or two about the street network in that city. You will need to label the streets as well, the lakes and the rivers. You will have many labels, so if your map is filled with labels, you might want to reduce the area of representation. Simply have a map of the city center only, or reduce the number of layers labeled. But the user of the map will need points of interest, so he can orientate himself. Alternatively, you can also place labels manually, which gives you more freedom to choose which labels you will place. This way you have the freedom where to put them and make sure they don't overlap. I will teach you how to put manual labels in Inkscape in the next tutorial. As you can see, the railway does not look very nice, since different tracks merge and diverge from one. We will need to do a trick to make the change more smooth. Double click on the railway layer, Style, Advanced, Symbol Levels, Enable Symbol Levels, click OK. So now there's one thick continuous line for the track. Much better! You can label and style the lakes and rivers also, with a nice bluish color. Since the name for the rivers does not get displayed, we will get more names from the line shapefile. To make sure the line and polygon type layers have the same color, copy the color from one of the layer and paste it to the other layer like this. Click Properties, Style, Color, click the drop down arrow, copy color. Then in the other layer, follow the same steps, but click on Paste Color. If you find the Lakes Rivers polygon type layer has rivers that are too wide, you can choose the river line type layer and represent that as wide as you want by styling it. But make sure you select the lakes from the Lakes Rivers polygon type layer as a separate layer. As you can see, making a beautiful looking map in GIS is hard. Labels are overlapping, sometimes there are more symbols than we actually need, and we have not even drawn the bus routes layer yet. So my solution for the bus map was to do it in a different way. Similar to a metro underground map, for those who are familiar, where we only care about the bus routes and the bus stops, and less about the roads. You could continue with this map and simply not show labels for streets, or you can redo it in my way in the next tutorial. The current map, we will still use it for the bike routes map, where the street network is important but the bus stops are not. So we will continue the project for the moment with the bike routes. To label only the important layers, go to Properties for the roads layer, Labels, Rule-based labeling, click the plus sign, Description equals Important roads. Click on the three dots button to the right of the filter row. In expression field type F-class equals, click all unique values to see which values to choose. To have more values labeled the same, type F-class equals, for example, residential, or F-class equals primary, or F-class equals primary link, and so on, until you have written all the classes that you want to represent with the same style. Since more segments are from the same street, there could be duplicate labels, so please go to Rendering, Feature Options, and tick Merge Connected Lines to avoid duplicates. So you will need the bike routes layer you created earlier. Hopefully you have found a good up-to-date source for the bike tracks. I will simply use the data from OpenStreetMap. If you want to do this, as I do, you have two options. You can select the cycling routes from the roads layer, or you can duplicate the roads layer by right-click on the layer and select Duplicate, and only represent from the duplicated layer the cycling tracks. Since I have already showed you how to select, in the previous lesson, I will take the duplicate layer option now. The duplicate function creates a new layer that has the same data as the original one. It is not stored on the drive, but only in QGIS as a temporary file. If you modify anything in the duplicate, it will have an effect in the original and vice versa, so they are still linked. There is no documentation I know of for this function, so it is more of a personal experience. We will not modify any of the features, we only want to represent the cycling tracks. You have to make the duplicate file visible, so tick the square to the left of it and drag and drop it above the roads layer. You can rename the duplicate by right-click and rename. To only show the cycle path, click Delete All from the Style tab, click Classify while having the F class in the Categorized column, and remove all the other features except for the cycle way. To modify a color of a feature, right-click Properties, Style, left-click the arrow on the right of the color, choose Color. You can put here HTML notation or input the RGB, SHV values, or simply pick a color to the left, either by option of color wheel, recent color, pick a color. If I want a map that has all the bike routes in it, I could zoom to the extent of the bike layer. This works best if you selected the bike tracks and created a new layer for the bike routes. If you made the bike layer by creating a duplicate, you will get to the extent of the whole area of interest as the first polygon created in lesson 4, unless you select only the bike routes and click on the button for zoom to selected features. You can also decide which area is more suited for your purpose. Maybe you only want to show the bike routes in the city center if the city is really big. Maybe you want to show all the bike routes. In the future you might learn WebGIS or making an app for mobile users. Obviously you will need all the data there, because users can easily pan around. However, on a printed map there is the map boundary limit. In the map composer you will need to put the map scale, legend, a title and a north arrow. Please join me in the next tutorial to show you how to do this. Thank you for watching this tutorial. All the best. Goodbye. We have already used some of the features of the map composer. And the reason I have done this is because it is easier to set the composer gradually for the purpose you have in your mind, and to make sure the layers are shown according to your desire and to the target audience of the map. Now I will show you how to add the legend, a title, the scale bar and the north arrow. First, we will start with the title. You need a catchy title, so why not make it a question? Like, where can you cycle in Oxford? Or, are you ready to use your bike? Find out where to cycle in Oxford. The title is like any other label you can create. And you will create it with add a label. You can use this feature if you want to add any label representing some points of interest, some cultural landmarks, like theater, church, airport names, rail stations. Maybe even if you see a label for a street or river is missing, you can place it manually. You can change the size of the title by dragging the corners. You can see in the item properties the current text. Simply click there and modify it. To change the font, click on the font. you can change the alignment, the position, you can rotate it, or create a frame around it and a background color. It's also possible to lock an item so that it becomes immovable. Therefore, you will not be able to modify it unless you unlock it. This can be useful if you're doing small changes to one of the features and don't want to make accidental changes to another. Simply go in the Items tab and tick the lock for the desired layer. Now we will create the legend. Click the Add a Legend button, then click on the map where you want it to be shown. As you can see, it is a huge legend. This is because QGIS shows all the elements in every layer that is in the Layers panel, even if you have not used them. We will be able to edit this legend either by removing the layers from the Layers panel or inside the Map Composer by going to Items Properties and untick the Auto Update. Now you are able to edit every layer. For example, we can remove the layers we are not using. Now, as you can see, the roads layer has every type of road in the legend. We don't actually need that. If you made a color or size distinction between each type, you will need each different type. Otherwise, you may need just two of them, one for the main type of road and one for the secondary type, because we made a size distinction. Residential and any car designated road are with 0.5 points, while footpaths are with 0.26 points in size. So in the legend we only need two entries. It would have been best if QGIS had an option to group them. Instead, we will need to delete all the types except for one of each type. To rename them, click on the type you want to rename and then click Edit Properties. Best practice is to put the layers that aid in orientation first on the legend, like contour area, rivers, lakes, roads, and the end ones should be the layer which is the theme of this map, bike routes. Use the up and down arrow to move them inside the legend. You can also edit the names that appear in the legend. It is not good to have a name like roads_OX. Please also change the name of the legend and its font. If you have many layers, you can put them on two or more columns. Same as for the title, you can create a frame, a background, or you can lock it in place. There is no place that is best, but try to minimize the features covered and to put it in one of the corners. Next, it is the scale. Now for the people that do not know this, a scale is a graphic representation that makes it easy for people to measure distances on a map. There are different types of scales. They can even show as simple numbers, like 1:10,000. Graphic scale bars are easier for people to imagine how much they have to travel to reach a certain place. Simply click on the Add a new scale bar. Items Properties allows you to modify some of its features. Style, make it a double box. Units, choose meters. You can choose whether you want to represent some units before 0 for measurement purposes. You can choose the number of units to the right of 0. There is no standard way of showing it, but you would need at least 2 units to the right of 0. You can change colors, create a frame and a background color. To create a north arrow, it is a bit harder, simply because there are no standard north arrows like you would find in other GIS software. But you can import an image, which can be a SVG file, or you can create a new arrow inside of the composer. It is unconventional but more creative. Now you have reached the end of the map composer. You can export it as a PDF, image, or SVG if you want to modify it further in Inkscape or Illustrator. I will show you what Inkscape can do in the next tutorial. Thank you for watching this tutorial. All the best. Goodbye.